Hello guys, so today we're gonna go over simplifying radicals. Yay! A lot of people tend to have difficulty with this because they don't understand the basics of it. Now let's go ahead and look at the diagram. I would highly recommend that you guys kind of just copy this down and then just kind of watch the video after. Things that you need to understand about radical. There's three things. We have the coefficient that we have on the front. That's just a number that's multiplied to the whole thing. We have the index. And the index is going to be very important. The index is just going to indicate what kind of radical you have. And now, what is the importance of this? This is going to be telling you, and it may not make sense right now, but it makes sense once we start working on the problems. It's going to tell you how big your groups are going to be. I'm just going to write it like that. But yeah, your index is going to tell you how big the group is. Now, inside of my radical, I have a number. We call that the radicand. Now this guy is very important too, because this one we have to break down. We always break down the inside, okay? We're going to break it down to the simplest numbers. All right, so that's the two things that you need to understand, the index and the radicand. The index is going to be a tiny number on top of your radical. Now, let's say you don't have anything on top of your radical. We're going to go ahead and imply that's going to be a 2, okay? And I'll show it on the next example that we will see. Second thing is that we're going to have to go ahead and simplify the radicand. Now, whenever you simplify the radicand and it is a number, we're going to have to find what we call prime numbers. Prime numbers are going to be numbers that the only way that you can get the number is by multiplying by 1. And this is what I mean. So 1 times 1 is the only way you can get 1. 1 times 2. It is the only way you can get 2. 1 times 3 is the only way you can get 3. Now, 4 is not a prime number. Now, the reason is because we can do 1 times 4 and 2 times 2. Okay, it has two options that you can get that number. A prime number is a number that the only way that you can get is by multiplying by 1. Okay, so that is a prime number. And I'm going to leave the prime numbers. I would copy them because those are most likely the prime numbers you're going to be using for most of the class. So 1, 2, 3, 5, 7, and 11. Just kind of memorize those and you should be good. All right, let's go down. On the delta that you're going to get today, you're going to see a problem like this. So we need to understand two things. My index doesn't have anything, so we know we're going to have an index of 2. Now, the inside of my radical is the radicand, and it's a 24. We're going to have to break that one down, okay? So let's start with the breaking down of things. So whenever you're breaking down a number, you're going to write it out, and then you're just going to find factors that give you that number. So, for example, what number gives me 24? I know it's 4 and 6. And believe me, you can do this in different ways. You can do 2 and 12. I believe you can do 3 and 8. So you can do a lot of different numbers. But I decided to use 2 and 4. It should still give you the same answer at the end. So then I know 4 and 6 are not prime numbers. So whenever you're breaking down, especially a number, you always want to go down to your prime number. So right now, I know I don't have any prime numbers yet, so I still have to go down. And if you forget what your prime numbers are, I have them right here. So just look at those. If you get to those, then you know you need to stop. So right here, we have 4 and 6. Those are not part of the numbers, so I'm going to keep going. So it's going to be 2, 2, and then 6 gives me 2 and 3. All right, so now I know all of those numbers are prime, so I know I need to stop. At this point, I'm going to mark off anything that's not a prime number. So that one, and that one. We don't care about those. We only care about the prime number, so that's going to be the 4 on the bottom. What we're going to do here is that we're going to be looking at our index, and we're going to see how big my groups have to be. So right here is telling me I need to do groups of 2. And you're going to do groups of 2. That means, like, if you have two numbers that are the same, you're going to go ahead and circle them. So for this one, for example, let's go ahead and circle those 2. And I'm going to underline everything else that doesn't have a group. Now, this is important. Whenever you simplify radicals, for the most part, you're going to write a radical. And there's going to be something that's going to go on the outside and on the inside. Okay? And this is how it's going to work. Any circles that you have we're gonna go ahead and we're gonna put them on the outside. Okay, now kind of like an analogy you can do this, like whenever you go dancing or whenever you go to prom or anything, homecoming, whenever you have a date, you usually go out, right? So you're gonna go out, you have a date, you're gonna go out. Now anything that doesn't have a date is gonna stay at home, and they're gonna be staying inside of the radical. Okay, so how is that gonna look? So be very important that you understand you can only take out one out of the group. So one out of group. I'll probably show like a different example just so we can go a little faster. So we're gonna take out one out of the group. So that was just gonna be 2. And then on the other side, we're gonna go ahead and we're gonna put the 3 and the 2 inside. Now, if you have multiple numbers either in the inside or on the outside, you're gonna have to multiply. So right here, we're gonna leave the outside alone. So my answer is gonna be 2 and then square root, and I'm gonna have to multiply the 2 and the 3. So it's gonna be 6. Okay, pretty easy. And that's how you simplify a radical. Now let's go ahead and do another problem, because I'm pretty sure you guys are like, okay, what the heck? It's a lot of stuff. Now we're gonna do letters over here, and we're gonna go ahead and do the same thing. But before we do the letters, let me do another example. So let's do the square root of a random number, 50. Okay, we're gonna do the square root of 50. So we need to break this number down. So I know that this one can be broken down as 10 and 5. And then 10 can be broken out. I stop at 5 because 5 is already a prime number, so I don't have to keep going on that one. Now on the other one, 10 and 5, 10 can be broken out as 5 and 2. But let me go ahead and switch the positions real quick. It's going to be 2 and 5. So I already broke everything down. I can see the 2, the 5, and the 5 are prime numbers, so I'm going to stop right there. And I'm going to mark off anything else that's not a prime number. At this point, this is what you need to do. I need to do groupings of. There's nothing here, so that tells me I need to do groups of 2. So if I see any number that repeats, I'm going to go ahead and circle them. So I'm going to circle those 2. Now, like we said before, the group is going to go outside. Okay? But you can only take out one out of that group. So on the outside, I'm going to put 5. Then my radical. Then anything that didn't have a partner is going to stay inside of my radical. Yes, I'm just going to put it, I should have put it on the other one. It's going to stay inside of my radical. So the 2 is going to be remaining on the inside. Okay. Now let's do one more just so you guys can fully understand this concept. So let's do what? Let's do 40. So 40 is going to break down to 4 and 10. And then 4 is going to break out to 2 and 2. 10 is going to break down to 2 and 5. And now you circle any groups. So I know I have a group 2 right here. So that goes on the front. And I have those 2 loners. So those are going to go inside of my radical. So it should look like this. So we can only take out one of the groups. So it's going to be 2 on the outside. And on the inside, because we have 2 numbers, what did we see before? We're going to multiply. And so on the inside, it's just going to be 10. And that's how you're going to go ahead and go about simplifying radicals. Now, last thing, let's deal with letters and radicals. Now, letters and radicals, they might seem very intimidating, but it's still the same concept. Now, in this one, actually, I believe it's a little easier. Now, we're going to be looking here. We're going to be looking for a number. And right here, we have no number, so we know our index is going to be 2. So that means that we need to do groups of 2. And the way that I usually go about doing letters is the following. We just expand it. So on the front, we're just going to leave it alone. We're not going to touch the front until the very end, so I'm going to box it. We're not going to worry about that yet. Now let's worry about what's inside of my radical. So we have x to the 7. Now the easiest way that you can do this is just by drawing it out. So how many x's do we actually have? 1, 2, 3, 4, 5, 6, 7. We have 7 x's. And what's going to happen is that we're going to try and find groups of 2 because it doesn't have an index. That means that we have technically a 2 up there. So, we're going to circle every group of 2. So this is going to be 1 group, 2 groups, and 3 groups. Now, underline any loners. That means that's how many you're going to be living inside. All right. Remember, this is important that you remember this. You can only take out 1 out of each group. So how many x's am I actually going to be taking out? If you said 3, then you are 100% correct. So we're going to be taking 1, 2, and 3 x's out of my radical. Now on the inside, there's only going to be 1 x inside. Okay, but don't forget, if you have multiple things on the outside and on the inside, you're going to have to multiply. So, okay, I know we haven't covered this. We're going to cover exponents in a little bit, but we're going to start seeing exponents a lot in the math that we do. So we have already x to the 5th on the outside, right? You see this guy right here. And we have 3 more x's on the outside now. So what we're going to do, we're going to be increasing the exponent by every x. So technically there should be an exponent of 1, exponent of 1, and exponent of 1. What we're going to do, we're going to go ahead and grab each one of those exponents. It's going to be adding up to that exponent. So instead of having x to the 5th power, we're going to have x to the 6th, 7th, 8th power. So on the outside, it should look like this. X to the 8th power, square root of x. And then we're done. And let's see if our answer is there. Yes, so my answer would be that one. I'm going to go ahead and explain this more while I'm in class tomorrow, but this is the basics of simplifying radicals. Now, there's going to be another section that's going to get a little harder, and that one I just want to see if you guys can do. I'm going to leave another video on there just for that one in particular because that one takes a little longer. But yeah, that's going to be the basis of how you're going to be doing the delta maths today. But before we leave, let's just do one more just for good measure. So we're going to have 3 or x to the 3rd power, and then we're going to have x to the 4th power. No. Yeah, right there. So let's go ahead and do this. Now, let's go ahead and worry about the radical first. So 1, 2, 3, 4. We're going to circle any groups that we have, and then remember the groups are going to go outside. This one's unique because we don't have anything underlined. I mean, we don't have anything left over, which this is actually going to be very important because we eliminate the radical. So if you're able to find a group for everything inside of your radical, meaning the radicand simplifies completely, at that point we can get rid of the radical. So in this case, we would have x to the 3rd power times x times x. Okay, there would not be a radical, so we don't have it anymore. And now we just have to figure out what this is, so that would be x to the 5th power. Because we already have 3 x's, you're going to be increasing it by 2, so now we have x to the 5th power. And that is my answer for this one. Alright, hopefully this helps a little bit, and I'll see you there tomorrow. Also, if you did not understand how I explain it, make sure you watch the Delta videos. They're really helpful too. So watch the Delta videos, and tomorrow we'll go over some more of this. Alright? I'll see you guys later.